Hello friends, in this video we will understand how LDP works. LDP has four major functions which are listed here: neighbor discovery, session establishment, advertisement of labels, and housekeeping using notifications. So let's discuss these functions step by step. In this video we will understand first three functions. Let's first discuss its first function, which is neighbor discovery. So LDP neighbor discovery happens on UDP port number 646. To enable LDP, we need to configure MPLS IP globally as well as on interface level of the routers. Let's consider this diagram where two routers are connected via a fast Ethernet link. I'm taking one naming convention for this link: 10.10.12.0/24, where .1 IP is assigned to R1's interface and .2 IP is assigned to R2's interface. So when we configure MPLS IP on fast Ethernet 1/0, R1 will send hello to R2, taking source IP as 10.10.12.1 and destination is all routers address 224.0.0.2. So in neighbor discovery, each neighbor would send hello to its neighbor on the link using source as its interface IP and destination as well-known multicast address for all routers, which is 224.0.0.2. Few other things to understand is that hello messages are sent every 5 seconds and hold on timer is 15 seconds. So in hello message there are few more things are carried, like LSR ID, which is highest loopback address of that router. So let us take one loopback on both R1 and R2. Say it is loopback 0. I'm taking a naming convention 10.10.0.1/32, and for R2 I'm taking 10.10.0.2/32. So the LSR ID is highest loopback address or highest IP address on router, say R1. So the LSR ID for R1 will be 10.10.0.1. There is one another term you will see in hello message, which is label space ID. Label space ID is actually 0 for per platform service. We're not discussing label space here. We'll discuss it in another video. So these two values will form LDP ID, which is of 6 bytes, 4 bytes LSR ID and 2 bytes label space. So this can also be written as 10.10.0.1 colon 0. So 4 plus 2 will make LDP ID. There are few more fields which are carried in hello message, like what hold down timer a peer is using. For example, default value of hold down timer we have discussed 15 seconds. And another important field which is carried in hello message is the transport address. So the transport address is one which is actually used to establish the LDP session. By default, the highest loopback address actually becomes the transport address with which the peers will establish the LDP session in step 2 of LDP function. It is very important to understand that this transport address should always be reachable. So if it is not reachable from any of the peers, we cannot move to step 2 of session establishment. On the screen you can see one of the Wireshark captures I've taken for hello message. Here R1 is sending hello message to R2 on the link. The source IP address is its fast Ethernet interface IP 10.10.12.1 and destination IP is 224.0.0.2 and it is using UDP. So LDP is working on top of UDP for neighbor discovery. So it is using source port and destination port as 646 because we are using UDP. So these are the fields of hello message. So as I had said, in hello message you would see LSR ID, label space ID. So the LSR ID is highest loopback address of the router, and the important fields which I mentioned was the hold down timer and the transport address which LDP would use in establishing the session in step 2. So by default it will take highest loopback address as the transport address itself. Coming on to the configuration, you can see that we have enabled MPLS IP on the fast Ethernet 1/0 interface of R1, and we have also specifically enabled MPLS label protocol LDP command. Sometimes in some routers this command is not necessary, so only MPLS IP would do the job. Now let us understand the command which we can check to discover the neighbors. The command is show MPLS LDP Discovery. So here you can see that we have fields local LDP identifier. So as I explained, LDP ID is of 6 bytes with 4 bytes as highest loopback address of the router and 2 bytes as label space. So here are the discovery sources. Discovery sources are the interfaces through which one of the neighbor is discovered. So R1 has discovered one neighbor which is connected via fast Ethernet 1/0, and it is using LDP protocol to discover the neighbors. There are few fields also shown, transmit and receive. So transmit and receive means that you have enabled LDP on both ends. Sometimes while you are configuring you forgot to enable MPLS IP command on one end, and you would see, like, if say we have not enabled MPLS IP on R2 side, fast Ethernet 1/0, then you would not see receive here. So it means we are only transmitting and we are not receiving anything from R2 side. We are only transmitting our hellos, but we are not receiving any hellos from this interface to which the peer is connected. And this is the LDP ID of our peer. So it has discovered the LDP ID from the hello message which R2 the hello message which it received from R2, and this is the IP address of the fast Ethernet 1/0 interface of R2. Let me also show you the importance of transport address. So in case the transport address, which I've said that by default the loopback address is taken as transport address. So if this address is not reachable, you sometimes would face issues in neighbor discovery. In order to understand the importance of the transport address, here you can see there is one of the issues. Uh, we do not have the route to this address. This address is highest loopback address of R2, and we do not have route to this LDP ID, and due to which we cannot establish session with R2. So we can discuss this detail later in this video. Now once the routers discover neighbors on the link through which they are connected, they move on to step 2, which is session establishment. Now let's discuss step 2 in details. After neighbors are successfully discovered, they move on to session establishment. Now session establishment happens at TCP port 646. We need to remember that LDP works or uses both protocols, TCP as well as UDP. So it uses UDP to discover neighbors and in step 1, and it uses TCP with same port 646 for session establishment. So session establishment, because it uses TCP, so the first step will be three-way handshake. So both routers R1 and R2 what they will do a three-way handshake. After three-way handshake is successful, they will try to establish session between them. So the first step you can say is three-way handshake. Now the second step, it is the label initialization message which both peers would exchange. And at third step they will advertise the labels. So these three steps will happen. Let us revise them once again. Three-way handshake. So if three-way handshake is successful, the TCP connection is established on port 646, and both peers will initiate label initialization messages. So label initialization message is actually used to negotiate few parameters. So these parameters can be timer values. So timer values for session establishment are 60 and 180. Like you must have seen this in BGP, like BGP peers keep lives every 60 seconds, and they have hold on timer of 180 seconds. Same thing is here. To maintain the session, the peers would send a hello messages for session every 60 seconds. It's kind of keep alive message, and hold on timer for the the session establishment or the session is 180 seconds. Another parameter which they actually negotiate is the label distribution method. So the label distribution method, we're not discussing this in details. I can give you a few examples, like LDP can use unsolicited downstream or downstream on demand method for label distribution. So here I'm not going to explain this. And the third parameter which the peers can negotiate is like VPI, VCI values, or if the link is frame relay, then they can exchange the parameters like DLCI ranges. So these are three main parameters which they try to negotiate in step 2 of session establishment. And once this is successful, they advertise the labels with or among themselves. Just a small correction. So we have mentioned step 3 here. Actually, this step 3 is we can discuss this step 3 as a separate step in LDP functions. So in session establishment, let's only consider step 1 and step 2. The first one is three-way handshake, and second one is label initialization, and where it tries to negotiate few parameters. So as I discussed, let's take label advertisement as we have mentioned. It is step 3 as one of the functions of LDP. So in step 3, after successful session establishment, each router actually would generate few local labels for all the connected or the routes which are present in the routing table of the router, and advertise these labels to its peers. I can explain you this in detail. Before that, let us discuss the session establishment step with respect to the configuration and so once the session is established, you can see the session between two peers using this command. Show MPLS LDP neighbor is the command which is used to see if the session is successfully established between the peers. So we are sitting on R1 and we are saying that we have successfully established one session with R2 whose LDP ID is 10.10.0.2:0, local identifier is LDP ID of R1, which is 10.10.0.1:0, and because in session establishment we use TCP instead of UDP, so here are the details of TCP connection. So it means that session was initiated by R2. Now state is showing to be operational. So if both peers have successfully completed step 2 of session establishment, you would see state operational here, and there are few messages sent and received, and here it is showing that one of the label advertisement methods, which is downstream on demand, means they have negotiated that they will advertise labels using downstream on demand method. Uptime of the LDP peer is 12 minutes 20 seconds, and we see few more lines here. LDP Discovery Sources. So in LDP Discovery Sources we will see the interfaces which or through which the session is established. For example, R1 is connected to R2 via fast Ethernet 1/0, and this is one of the IP addresses which is configured on fast Ethernet 1/0. So this is the physical interface IP of fast Ethernet 1/0 of R2, through which it has discovered R1 has discovered it means R1 has discovered R2 via fast Ethernet 1/0, and this is IP address of that interface. And you can also see few more lines here. Address bound to peer. So these are the IP addresses which actually are bound to R2. So it will show the IP addresses of all the interfaces which are configured with LDP. So on R2 we have two interfaces configured. Like first is it's fast Ethernet 1/0 whose IP is this, and we also have uh, its loopback address. So there are no more interfaces configured on R2 which are running LDP. Sometimes it happens that while you run show MPLS LDP neighbor command, which is used to check LDP sessions, means step 2, you won't see any output. Now I have tried to simulate the thing. Now I'm trying to run the same command to check establish sessions. Show MPLS LDP neighbor. So you see we didn't get any output. So to troubleshoot that, let us try to check whether step 1 of LDP operation is fine or not, which is neighbor discovery. So I'm running show MPLS LDP discovery. So as I've mentioned, you can see here the issue is that we do not have root to LDP ID of R2, which is 10.10.0.2. So let us check show IP root 10.10.0.2. So it does not exist in the routing table of R1. So let us see what's the issue. Show run interface loopback 0. Here you can see this loopback 0 is not participating in IGP. So this is one of the issues which we have discovered. So let us enable IGP on loopback 0, because if this loopback is not reachable, we will not be able to move to step 2. So IP OSPF 10 area 0. So as we configure this, we could see that LDP session would come up. You can see the message. Now it has come up because the LDP ID of R2 was reachable. If you run this command now, you will see that the session is established. So the error which we saw for LDP discovery would also be gone. So here you no longer see no root. So one of another methods to fix this issue is using transport address. Let us try to simulate it. I'm again removing OSPF from loopback 0, and I'm trying to simulate the same issue. I'm clearing the session once again. So here you see I've cleared the session, and I've also removed IGP from loopback 0 on R2. We try to see the session, show MPLS LDP neighbor. So we don't see any session. So to troubleshoot that, let's see whether it has completed step 1, show MPLS LDP discovery. So here you see there is no root. So now there is an alternate for this. Say we want to make the LDP session up without advertising loopback 0 in IGP. So we can do this way, int fast ethernet 1/0, which is the physical interface connected to R1. So I'm using one command. So I'm changing the transport address because by default we had discussed that LDP would use highest loopback address as the transport address, which is not advertised in R2, and due to which R1 is not able to establish the session. So I'm changing the transport address to its physical interface IP. So we can see we would see that LDP session would come up on R1 shortly. Here you can see now that it is using IP address here specifically. So we have specifically changed the transport address. Now it is not using its default loopback 0 as transport address, but it is now using specifically its physical interface address. And because R1 can reach this easily because it is the interface IP of its own link at other end. So you can see here, or you can also consider it that it is IP address of its connected link. So here the session has come up, show MPLS LDP neighbor. So now we'll get the output. Here you can see now the TCP connection is not established using loopback 0 of R2, but using the physical interface address of R2. So this explains the importance of transport address in LDP. So just to revise, by default loopback 0 is considered to be transport address, and if the transport address is not reachable, we cannot establish successful session between both peers. And to do so, either we need to check the root for the transport address or highest loopback address of that peer, or otherwise you can use an alternate method of changing the transport address at interface level command. So here you can see that we changed transport address manually to its physical interface IP by going on R2. Here you can see in Wireshark captures that after successful hello message or neighbor discovery, uh, three-way handshake has started, and after three-way handshakes is successful, the peers will send initialization message, which is one of the part of step 2, and both peers will try to negotiate few parameters. And in step 3, which I mentioned that we'll discuss later, so this is in step 3, they will actually start advertising labels which they have assigned to their prefixes to its peers. So let us discuss this thing in detail. So here you can see in this diagram there are two prefixes connected to R1. It's loopback 0 and it's one of the network addresses on physical interfaces, say F1/0. So what R1 will do is generate two labels for these two prefixes, because these two prefixes are locally connected to R1, so it will generate a label 3 which is implicit null for both prefixes and will advertise it to R2, and R2 would also do the same thing. It will generate label for the prefixes loopback 0 and its physical interface network and send it to R1. So this can be seen using a Wireshark. You can see these two messages where R2 is sending label mapping message to R1 and then R1 is sending its label mapping message to R2. So I have opened one of the label mapping messages which is sent by R2 to R1. So you can see few fields: LSR ID, label space. The important thing which we need to notice is this label mapping message. In this label mapping message we will see the FEC element. So FEC element is R2's loopback IP 10.10.0.2, and there is one generic label which is 3, which is implicit null, and it is advertising this label to R1. And same thing for its connected physical interface prefix 10.10.12.0, and it is again advertising label 3 to R1. In similar way, R1 would also advertise the labels which it has generated for all the connected prefixes to R2. Now coming on to step 4, just to give you brief information about this fourth step, which is housekeeping using notifications. So LDP uses this fourth function just to report or indicate or notify its peer about some errors LDP peers or LDP has encountered. For example, there is uh, an issue in on a link, and due to which LDP session uh, uh, actually got disturbed, and because the keep alive timer or hold down timer, which was 180 seconds, got expired. So when the hold down timer would expire, a notification will be sent to the peers to identify or to update them that the LDP session has gone down, because the the hold down timer for session establishment, which is step 2, is expired. So it uses a few more say examples, or it uses some more functions to notify its peers about some issues related to LDP and its operation. I hope this video was informative for you in understanding the basic function of LDP operation, and I thank you for watching. Please keep tuned to get some more useful videos related to MPLS. Please subscribe to my channel. Thank you.